Have you ever downloaded a new dataset and just wished you could ask it a question? I've wanted to do this for about as long as I've been involved in data journalism and data analysis. Up until recently, a declarative language like SQL was the best bet. You can't ask a question using SQL though. You have to convert your thoughts and your ideas into syntax, table joins, filters, etc. In this video, I'm going to show how some new AI technologies, like local large language models, and new strategies, something called reason and act, you can combine them to be able to ask questions directly of your data and get good results back. And at the end of the video, I'll release some source code so you can try it yourself. To illustrate how all of this is going to work, I built a very simple flowchart. It starts over here with building a prompt. We're going to ship the prompt over to the large language model. Then we're going to parse whatever it responds with. And if it says that it wants to run an action, that will trigger a Python function to run. The output of that Python function will then get added to the prompt, which we will then pipe back into the large language model. And this basically is all part of something called reason and act. So specifically, the way it works is it all starts with a question, which is the thing that we're trying to answer, the thing that I'm asking my data. And here in the example is I'm asking what information do I have about users. Reason and act starts with a thought, and the model needs to begin with stating what it wants to try to do. Here, the example is I should check to see if I have any users tables. The first action that's going to use is called tables. I'm going to intercept the output of the model. I'm going to see the action tables, and then essentially we're going to run this Python function here. That function is going to result in this observation with this list. You can see how this list becomes this here. And then we're going to pipe this back to the model, and then it's going to come around for a second pass with a subsequent thought. So on the second pass, it has a second thought of I should inspect the columns on the users table, and then it's going to say it wants to do an action of columns, which is another one of the actions I provided, and then also it has an argument of users. So it's going to inspect the columns on the users table. My code will then intercept this response. It'll see an action input, and it'll execute this Python function, which goes into the database, looks at the table, and returns the columns. And you can see the result here, the observation. Here are the columns for the users table. Again, we'll turn over execution to the model, and then it has a final thought. I have all the information I need, and it has a final answer. I have the following fields about users, and it lists the columns that are on the users table. So this is a very simplified example of how reason and act works. We're going to be using this. We're going to be expanding upon this to try to see what kind of tools, what kind of actions a model needs in order to be successful to answer certain types of questions. And really the kind of questions I want to ask are like a little more vague. Like, for example, what types of questions related to work and finance could we ask given the data available? And here's a trace that I actually ran. Basically what it's doing here is the first thing it does is it looks up all the tables in the database. So it grabs the tables. Then it goes through each of the tables and it looks at the column names. And then once it sees the column names, it comes up with the final thought. We have enough information to create questions related to work and finance. And the final answer is based on the data available, we can create questions related to work and finance, such as what type of jobs are available, how much do these jobs pay, are there any requirements such as age verification status, etc., etc. I'm going to go into two strategies. The two strategies for kinds of tools to give the local large language model. And the first one is I'm going to give it some actions that mimic using the data as if it were interacting with a tool like dataset. So that's going to be like being able to list tables, being able to list columns, being able to do facets. Like right now we're faceted on the preferred contact link type here. And there's also a facet on is contact allowed. So giving it the ability to, facet columns, see what values and counts are available. And then also the ability to see a row based on a specific facet option. In the second, more advanced set of tools I'm going to give it is I'm going to see if the local large language model can actually execute SQL queries. So in this case, we would give it the ability to look at how many tables there are. We would give it the ability to see which columns exist on the tables, And then beyond that, we would just give it the ability to execute raw SQL queries. And, obviously this has a lot more possibilities, can be a lot more powerful, but also maybe won't be able to do it. Maybe it'll get confused or stuck in holes. I don't know. These are the questions that we're going to answer though, and let's get into it. So this is the React paper, Synergizing Reasoning and Acting in Language Models. And it's a way to get language models to work better in situations where they haven't been trained on the data that they're interacting with, or if they're like hallucinating a lot, or if you want them to be able to interact with specialized systems, React is a good way to do that. Don't be confused with React, the JavaScript language. This is React as in reasoning and acting. So here's an example of React. First thing is you give it a question. This is the thing that you want the language model to figure out for you, to answer. And the example here is, aside from the Apple Remote, what other device can control the program Apple Remote was originally designed to interact with? And here is the React prompt strategy. And the way it works is the language model is instructed to respond with 3 formats. First thing is it's supposed to construct a thought, then act 1, so this is action 1, search Apple Remote. And what this is basically going to be like a Google search for Apple Remote. And then observation is the result of that Google search. And then the language model continues. Thought 2, okay, Apple Remote was originally designed to control the front row media center program. I need to search for front row next and find what other device can control it. So that now it's on its second action, search for front row. And then observation 2, which is the result of that search, could not find front row, similar, so it gets an error. And then we see how the model deals with this. Thought 3, front row is not found. I need to search front row software. And they do the search again, and then here we go. Front row is a discontinued media center software. And then thought 4, front row software is controlled by an Apple Remote or the keyboard function keys. So the answer is keyboard function keys. Finish, keyboard function keys, which is the correct answer to this query. So we can use this to do lots of things. And my interest in it is, can we get a language model to essentially operate our data? Can we get to search data for us, sift through things, sort things, filter things, maybe even write queries for us? That is the goal here, and that's what we're going to explore. What I have done is taken this strategy, this React formula or format, and used it to allow a large language model to interact with the SQLite database. And here's my prompt. Answer the following questions as best you can. You have access to the following tools. And the tools are tables, useful for getting the names of tables available, no input, so it doesn't accept any input, just returns the names of the tables. Columns, you can look at all the columns for a given table. Input 1 is the table name. Then we have a facets action. You can get all the unique values and counts for a given column. And the inputs are table name and column name. And then we have a filter. It gets the first row where the column matches a given value. The inputs are table name, column name, and a value to filter on. We're putting this into our prompt, and then we give it some examples. So the first example is just a general template for it. So it's question, the input question you must answer. Thought, you should always think about what to do. Action, the action to take should be one of, and then my actions. Then action input 1, the first input to the action. Action input 2, the second input to the action, if more than one. And then observation is the result of the action. And the way this works is we ship this prompt off to the large language model. We use observation as our stop word. So if the language model outputs observation : we stop. Then we parse this here. We look for action, we look for inputs, and then we pass them off to a function, execute that function, and then paste the result of that function here for the large language model, and then turn control back over to the LLM and allow it to go. And it'll go in a loop until it arrives at an answer. And that's at least what we're going to test. I have a couple examples here. The first one is, what information do I have about users? Thought, I should check to see if I have any user tables. Action tables, and then we give it the names of all of the tables. Thought, I should inspect the columns on the users table. Action columns, action input 1 is users. so that we're going to get the columns of the users table. And then here are all the columns of the users table. And then thought I have all the information I need. And then here's the final answer. I have the following fields about users and then all of the columns. And then I have another example. Okay, I had a mistake. It's very important that your prompt is in clean, concise English as best as possible. Large language models are very sensitive to the wording that you use, and they can easily get confused if there's typos or ambiguous wordings. So you got to be very careful here. So my first example was what information you have. Users kind of showing it to how to use the tables and the columns commands, and then what job types are being offered. The goal here is to show it how to use tables, columns, and then also the facets to get some of the information that it needs. So as I build this out, I'm going to add more examples, more commands, and kind of show it roughly how it can use the tools it has to answer certain questions, and then hope that it can take this and kind of run with it. And I'll say what I'm doing here is based off of this blog post. This is really good blog post. You should read this, but it's about re-implementing something called LangChain, which is essentially this, but it's like a huge framework and it's very complicated. Re-implementing in 100 lines of code. And this person did this in JavaScript, and they really laid everything out nicely. So I'm using a lot of their work to do what I need here. And I was able to take this and essentially implement my own LangChain in less than 300 lines of Python. All right, so I'm going to run this, and the first question I'm going to ask is what kind of data do you have available on experiences? Let's call it work experiences, because that's what it is. Okay, so this is my initial prompt here. These are my examples, and then we say begin, question, and then here's what I typed in. Now we're going to wait for the language model to go. Thought I should check if there's a table related to work experiences. Now it came around for a second pass. Thought I should see the columns on the experiences table. Action column. Action input 1, experiences, and these are all of the fields on the experiences table. Okay, now it's doing something curious. I should get the unique values for job role. So it is asking for faceted values on the job role column of the experiences table. I should check to see if there's a table related to teams. There's no teams table. So it's kind of getting lost. This happens sometimes. I should see the columns on the teams table. There is no teams table. Thought there doesn't seem to be a teams table, so I can't get information about team names. Final answer. Based on the data available, there is no information about work experiences other than the job roles and number of jobs for each role. The job roles and their counts are as followed: builder, modeler, scripter, programmer, and modeling. So it actually was able to do a good job. It was able to look at the fields on the table, and then it kind of started looking for other stuff. I don't really know where it was headed with that, what it was going to do with team names, or why it thought that was important, but it's kind of interesting. One area for improvement here is when it passes a bad argument, this really should return an observation that is, there is no tables team, or something like that. If it tries to call facets without the right amount of inputs, it'll actually be like you're missing one action input, but when it passes the incorrect column here, it's not checking. So that's something I need to improve. Okay, and let's ask another question. What is the most popular type of skill users have? Start by finding out what skills are associated with users. Columns. Yep, so it knew that we have a users table from the previous examples. Skill types. Yep, and here's that error. Columns and users. There's only one argument here. It should just be users. It's lost. Okay, I'm using a small model that is very fast, but also kind of error prone. So let's just run it again. What is the most popular type of skill users have? Good. Off to a good start. It wants to look at the tables. I should see which columns are available for users. Very good. So it asked for the users table columns and it received them. Great. And now it's going to use the facets feature to look for the unique values in the skill types column for the users table. And then here it has the skill types right here. This is another example of it kind of overreaching. I should filter the users table to only show users with a specific skill type. That one only returns one row at a time, so it's not going to be able to iterate over all the pages. But I've noticed this pattern where it seems to like try other avenues, and then if it doesn't work out, then it's like, okay, and then it has the answer. And it ended up with final answer. The most popular type of skill users have is modeling. 5,788 users. So these are simple questions. This is not the most complicated stuff, but I want to add more columns. I want to add more features. I want to see if the model can even write SQL queries, because then we could start asking it more interesting questions. Here's the kind of question I want to ask the model. What types of questions could we ask about users given the data available? So I want to know if the model can come up with, interesting things to be thinking about from the data, things that didn't necessarily occur to me. And I don't know that it has the right capabilities to do this right now, but let's just see how it goes. Okay, very, very odd, very interesting. Okay, it actually just spit out its own entire trace, because my code does not do observation 1, observation 2. It doesn't do that. No, this is not my data. Okay, so it did something really weird. So the reason I know this is fake is because the is public, these values are 1 or 0. They're never true or false, and they're certainly not strings. And these numbers are incorrect. So it completely made these up. Like, the foundation of this is valid. We can ask about the numbers of users with public and non-public profiles in the data. Yeah, so we can do that right here. Is public integer on table users. So let's just look and let's just see what it did, just to compare the numbers here. Okay, this is really funny. So, and this makes sense because the data that I have, it's only public users. There's no private users in my data, because if they were private, I wouldn't be able to see them. So this is fake. And if it had faceted on that, it would know, but it didn't. It created its own trace here. I'm going to keep playing with this. I'm going to give it some SQL capabilities. I'm going to give it more detail and more examples, and let's just see how it goes. I've written a new version of the script with some new actions, and it's all oriented around executing database queries. So now we just have 3 actions. We have tables, which will list the tables. Schema, this will list the schema, the SQLite schema. So that's going to be the columns and the data types. And then SQL query, and then this will accept a query and will return the top 5 results of that query. And I'm hoping that this will be enough for the language model to be able to answer more complex questions. I've adapted my prompt a little bit, and I've given some different examples. So the first one is really about teaching it how to use the tables and the schema commands. And the second one is about using the tables command and then the SQL query. So this one is just asking for a simple count, just kind of showing it the format. We're using triple backticks for the observation output, the SQL query input. So now I'm going to run this. I'm going to test it out. I'm going to say, what is the highest paying job, and see if it can figure all of that out. Thought I should first look for a pay column in the schema of the jobs table. So it's looking at the jobs table schema. There is no pay column, but it might be able to pick up on the fact that there's a payment amount float column. The schema shows that there's a payment amount column, which represents the pay for the job. I can use SQL to find the highest paying job by querying the table and sorting the results. Very good. Okay, and then here it got the first results. Yep, payment amount. That looks like the biggest one I've seen. And then thought, yep, this query has returned the highest paying job. Final answer, the highest paying job in the database is titled Hi, I'm looking for a scripter to make a teleporting pad with a payment amount of $100 million. Clearly, there's no validation going on in this database. I feel like that did pretty good. It was able to look at the columns it has. It was able to successfully create SQL that answered the questions. So now let's ask something else. Okay, the next question I'm going to ask is, do jobs have age requirements? There is no age requirement column. Maybe we should check the SQL query results to see if there's any information about requirements. And then it's going to select star from jobs. It's going to try to look through the entire database. No. Okay, that was a failure. That is the way a computer would try to do it. Go through every column and look. It's not using any of the columns, though, so that is unfortunate. The thing with these language models is if you get a bad result one time, if you try it again, the second time you might get a good result. You just got to try it a couple times sometimes. There is at least one job without an age requirement, but I need to check if there are more jobs with no age requirement. SQL query. The final answer, yes, jobs have age requirements. Okay, let's ask a follow-up question, because that was kind of a vague question. New question, what job has the lowest age requirements? My script has some errors happening. I need to fix that. So let me debug this. I'll come back and we will ask this question again. It's been a few days, but I've changed my script up a little bit. I have added a new action here called context, and this will give information about the table and kind of allow the LLM to have some hints about what to do or what kinds of things will or won't work. Because one of the problems I noticed is it would kind of try to infer things from the column names, and it would also try to like guess about relationships between tables. So I'm hoping that what the model will do is when it tries to like formulate a thought, formulate a plan of action, it'll then go to the context to get more help and see how to do certain things. So I've added all this context about all the tables. For example, the users table just says individuals who are seeking work. Sometimes they mention demographic information about themselves in their description. So that's a hint to the language model to, if we're looking for the age of the person, we can search the description. So I'm hoping that the model will be able to use this. Some people will try to like insert all this information into the prompt, but it's just too much information. We don't have very much space to work with these local large language models. We only get about 2,000 tokens, and that goes fast. I'm going to ask it my original question, what job has the lowest age requirements, and let's see how it does it this time. Question, what job has the lowest age requirements, and let's see its plan of action. I should use a SQL query to find the minimum age requirement in the jobs table. So I updated my script, so it'll give back errors now if it tries to guess a column that doesn't work. Your query has an error, no such column, jobs.age requirements, because it needs to actually look at the columns in the table first. So I've noticed that when I give in the prompt example columns, it tries to like extrapolate from that as opposed to using the action sometimes. So I might need to actually rework my prompt to show it using the different pre-SQL query prompts better. This is another thing I've seen it do. So the thought is the database doesn't have a column called age requirements. I should think of another approach to this question. And now it's trying to do this action context comma SQL query. So I've seen it try to like merge two actions together in a single prompt, which is just weird. That's not in the prompt. I should look at the jobs table schema to see if there's another column that might represent age requirements. So it actually is going to look at the schema for the jobs table now. And that's exactly what we want it to do. Thought, the schema shows that the column representing age requirements is min age requirement. I should use a SQL query to find the minimum value in this column. So SQL query, and it is going to grab the minimum age requirement from the jobs table. And it got the result, min age of 0. This is actually kind of a trick question. Nobody has a minimum age requirement in this entire database. So trick question, but the model was able to find it. Here's its final answer. The job with the lowest age requirements is one that requires no experience, 0.0 years. I'm going to change my prompt. I'm going to have it use context before tables. Let's do that. There we go. So by adding these prompts, you can kind of guide the model towards using certain tools, using certain strategies. It's really a process of refinement here. But if you find that it's not using the actions properly or not using them in the way that you want, the first good option is to go through your prompt and like revise it. What are some ages of users? And let's see if it can pick up on the fact that there are ages sometimes in the free text description field in the users table. You probably can't pick it up, but anytime I hit enter on this and it starts running the model, my CPU fan just starts going pretty hard. These language models do require a bit of resources. I've got it until 13th gen, and that thing will just crank the voltage all the way until it gets to 100C. So that thing goes hard, and this entire room will get heated up if I run a model like overnight. The first thought here is I should check to see if there's an age column in the users table. It grabs the schema. Second thought here is there's no age column in the users table. Now it's gonna just try to grab the schema. Okay, so it's like very confused. Let's see if it can use the context. All right, thought. I don't have an age column in the users table, and it doesn't seem to exist in any of the other tables either. SQL query. Now it's just going to count the number of unique users in the table. Okay, it's lost. Now it's just going to count the users. Again, if the model starts to do something really stupid, or if it just gets stuck, sometimes you just got to run it again and you'll get a better, at least different strategy. Maybe it'll try something different. There's some randomness involved here. So it's annoying, but trying again often helps. Okay. It's trying the same first thought, which is to look for an age column in the users table, which there's not. Let's see if it will use the context. Okay, again, looking for the age column, which does not exist. Always seems to do that. It's good though. We want to use the schema command first. Very odd. See, when it does this, when it just says, I should try another approach, it almost always just goes in for a random SQL query. So we are going to end that. Let's revise my prompt. I think that's the problem here. And let's really think about what I am showing it. I want to take a second to talk about the model I'm using. Using this XWin 13 billion. I'm using the 6-bit quantization. It's kind of hard when you're developing on these because there's a big trade-off between the amount of time it takes for it to run and the quality of the output. So there's like smaller models or smaller bit sizes for the quantizations. They'll make it run a lot faster. And it'll increase like the round trip time on how long it takes for me to try something, see if it works or not, and then mess with the code or the prompt and then run it again. But at the same time, the smaller models do worse more frequently. So like I'm just going to be like going around in circles if it's too weak. I've tried with the 70 billion model size. They work much better, but they also take so much longer. My prompt is not perfect yet. There's still some things I need to tweak. So I've settled on using this one, the XWin 13 billion. Again, I feel like it's a good trade-off. It runs pretty quickly and it has pretty good output. Okay, the description column doesn't contain any information about user ages. That is incorrect. A big part of the prompt engineering of this is really understanding your use case, really understanding the kinds of questions that you want the model to be able to answer. And then with this SQL querying thing, architecting the database in a way that's easy for the large language model to like navigate. 2, using very descriptive columns, because you can see it's like trying to guess the names of columns that are just slightly wrong. Like the users table doesn't have a descriptions field, it has a creator description field. And the smaller models sometimes have trouble like picking up on those small differences. Okay, so what did it do? First thing it did is look at the schema of the users table. Very good. Second thing it noticed is there's no age column. Try another approach. Its second approach is to use the help function. Observation. A free text field the user has supplied, describing themselves, their interests or work references, and occasionally age/location. Thought. Sometimes users mention their age in their creator description. I can analyze this data to find common age ranges. What it's going to do is it's going to count the number of instances where the user creator description contains the word age. Oh, and it's going to do it for 20s, 30s. Yeah. The people in this database typically use years old, not age, not anything like that. So let's see if it'll figure something out before it runs out of space. And that's another thing. There's another trade-off here is sometimes the model will just do something that is so bad that your code's just going to explode and then you just want to try again. But other times it's like subtly wrong and it needs a hint. So in that case, add a try except, try to return some helpful information back to the model and usually it'll correct itself. All right, so for some reason it was looking for the string birthday in the created.column, which is interesting, but also that's not going to work. So let's try again. With things like it's getting the column name wrong, it's getting confused, that's like a hallucination thing. That's where it's like it saw the correct text, which is creator description. But then in the context of outputting the thought of like, I should look at the blah, blah, blah column, it's kind of looking at the most common name for a column. And in this case, that would be description, not creator description. So it's getting confused. A larger model would be able to do this better. So this is a case where the 13 billion is actually hurting me. So it's like looking for essentially a birth date. I'm going to give it a hint now. My new prompt are, what are some ages of users? Hint, some users may use years old in their descriptions. Okay, a more on the nose hint. What are some ages of users? Hint, some users may say things like, I am 20 years old in their description. See if it can figure that out now. First thought, I should first check the tables available. Got the tables. Second thought, I should use the help action to find out if there's any age information in the user description. So the action help, it's going to look and it's trying to do the description column again, which doesn't exist. Let's see if it can fix itself. Or if it's going to do a wild SQL query now. All right, there doesn't seem to be an age field in the users table, but users might mention their age in their description. I should use the SQL query action to find instances of ages in user description. So it's going to try to use a regex, but I don't have the regex function. Now it's going to try to install it. Let's run it one more time. See what we get. Come on. Roll the dice. Roll on the dice here. I should look at the creator description column in the users table to find age information. All right, so it pulled that from the prompt. Very good. Okay, so it's using the help command correctly. And now it's second thought here is I can search for specific phrases related to age in the creator description column. SQL query. Select users where description like age or years old. Limit 3. So, okay, so I actually I disallowed it to do things like that, select star, because it was just doing that to get the list of columns. So let's see if it can actually select some specific columns now, not just everything. Thought, I should specify the columns I want in my query, SQL query. Select user ID, description, and then the rest of the query. Same as before. Very good. Now it got some results. Final answer. Some users have mentioned their age in their description. For example, user 1 is 18 years old, user 2 is 21 years old, and user 3 has a bachelor's degree in software engineering with over 2 years of experience. It kind of inferred this person's age by the fact that they have a bachelor's degree, which is interesting. So it made this up. This person never said they're 18. Let's see if this person said they're 20. Oh yeah, here we go. I am a 21-year-old within. I'm also a retired firefighter, 21 years old and retired. Interesting. All right, so it was able to do it. It was able to do the search that I kind of made it do. It was able to pull a couple fields back. It was able to infer the age of someone who didn't actually put their number age in here, but it also invented an 18-year-old. This shows how, with some careful prompting, some, careful guidance, like I had to tell it to look for years old. That's because I know the schema better than it, but you can get it to do things that are like quite advanced, just with a little bit of help. Just to recap where we've been, with the interface strategy, we were able to answer simple questions. The very first question I asked, what kind of data do you have available on work experiences? It was able to do a fastest action and grab the most popular skills. That was good. The second question was, what is the most popular type of skill that users had? That's a similar question. The first time it failed due to just random error, but the second time it was able to pull the most popular skill that users had using a group query, and it pulled it back. The third question is where I was starting to get into more vague, more opinionated questions, and that was, what types of questions can we ask about users given the data? It failed. It tried to create its own observations. It wanted to look into the is public column, and then it just hallucinated a bunch of information. With the SQL query strategy, it was able to do well with simple stuff. The highest paying job question, it was able to pull back a record where someone was looking for a scripter and they were offering to pay $100 million. So this kind of revealed the fact that people can basically put whatever amount they want in there, and there's no way that they're enforcing people to pay $100 million. When I asked about, do jobs have age requirements, and remember, this was kind of a trick question. The very first time it failed. It tried to iterate through every row. That wasn't going to work. And then the second time I asked, it said, yes, jobs have age requirements, but it said that the age requirement was 0. And to me, that's like, is that really an age requirement if you say 0? When I asked it what job has the lowest age requirements, the success came back with the job with the lowest age requirements is the one that requires no experience. So this did well. It was able to get the correct value and also make the correct conclusion from the data. When I started to get into trouble, that was with the what are some ages of users. I was hoping that it would use a group by and do some more sophisticated aggregates and also use text searching, and it just completely failed. It really relied on columns for a lot of the stuff. It just wanted to do simple sorting, simple grouping, just purely based on a column value. And when I wanted it to do, text search, it really flailed. I got 5 failures with just the simple question, what are some ages of users? Then I tried again with, I gave it a hint. Some users might use years old in their descriptions. And then I had to give it an even more obvious hint saying some users may say things like, I am 20 years old in their description. The first time it failed, it tried to use regex. I didn't have the regex SQLite extension added, and it thought it could install it itself. That was its first thing to do. And then when I asked it again, it did a query that pulled back any rows that had the words years old or the letters A-G-E. When it read those columns, it made a mistake. It hallucinated an 18-year-old. The person never said their age in the first one. The second one it got correct. The person said they were 21 years old, and it got that correct. And then the third user, that record they got by accident because it matched AGE. But it was interesting because the person did say that they had a bachelor's degree in software engineering, and it thought that that was relevant to the age question. The original question was, can we ask the model more important questions, more vague, more top-level questions? So I tried some of these. The first one I asked was, which questions about jobs of journalistic interest can be answered given the data? Give 3 examples. And the result I got was, we can answer 3 questions about jobs: how many jobs have been offered, what types of jobs are available, and what are the most common payment amounts for jobs. And it also had answers for each one. It pulled the number of jobs, it pulled the types of jobs, part-time, full-time, and commission, and then also the most common payment amounts, $0, $1, and $2. So this really showed everything come together, or did multiple queries, combine it all into a single answer. I feel like that's a good success. The second question was, are there any instances of games inappropriate for minors? Give 1 example. This is another interesting result. Its answer was, one example of a game that might be inappropriate for minors is content deleted, with the reason prohibited value of asset unapproved. This could indicate that the game contains content not suitable for all ages. However, please note that the provided information is based on the data available in the given SQLite database, and additional context or moderation might be required to determine if a specific game is appropriate for minors. You can sense the model leaning back on its safety mechanisms, right? It's not going to tell you certainly yes or no, this is inappropriate, but it did flag this record. It would be interesting to see what the content was before it was deleted, and it would be also interesting to see what other kinds of reason prohibited values exist in the data set, and what other things that had asset unapproved were like. So in my opinion, this is a hit. This is a good result. This is a example of what a model can do when it can properly go through the data. And the last question I asked was, are there any jobs that are inappropriate for minors? Give 1 example and a reason why it's inappropriate. So it searched through the data, looked at the schemas, it pulled some records, and then it came up with a series of thoughts. Its final answer was, yes, there are jobs that are inappropriate for minors, such as the donation game and looking for an investor to invest in our game studio. So the model was able to pick up on the fact that there's jobs, there's stuff that's asking for donations, they're looking for investors, and there's no age requirements. In any normal job environment, this would be illegal. And the model picked up on that. This is the perfect example of a language model taking context about law, about labor, about jobs, and then applying it to the database, pulling records out. It did some advanced queries here, and it put it all together, and it came up with a good answer. This is exactly what I wanted to see. I'm releasing all the code that I used to make this video. So that's going to be the dataset interface, the SQL query interface, the Python scripts, all that, and some short descriptions on how to get this going. It's going to be on GitHub. I will put the link in the description. It's pretty easy to get set up though. Just install the dependencies. You'll need to download a local large language model if you want to use it. I recommend this one right here. There's a link on the GitHub. You'll provide your own SQLite database. I'll probably put an example in here. And then you will update the data help if you want. And then also the prompt, so that this is specific to your data set. And then after that, you just run it. Just give it questions on the command line. If you want to know more about this or see future developments, I'm going to be working with this stuff more in the future. You can follow my website, bxroberts.org. You can subscribe here. I have a mailing list. There's a lot of ways to contact me. So feel free to reach out, and I'll see you in the next one.